Hello everybody and welcome back to another video. Now, the first thing you may notice could be the second thing that you may notice. And if you notice the second thing before the first thing, then explaining the first thing before the second thing wouldn't make much sense. So, actually it probably would make sense. However, then the second thing wouldn't be answered before the first thing. So, first thing you may notice is what happened to the regular Saturday series. Well, that's a good question. And the answer to that question is simply the power cable for my computer. The power adapter for my laptop is dead, and so I can't use my laptop to do what I would normally do. So this is kind of something I've been wanting to do for a while, so I figured might as well do this, seeing as I don't need my laptop for it. I can just use my iPod to record with. But the second thing you may notice is the writing on the piece of paper, which is kind of obvious. It just basically says this is a piece of paper, except piece is not the right kind of piece. So there's piece, except that that's the wrong spelling, so that's a pie. There you go. So anyways, so let's get down to business. What we are doing today is I'm going to be basically explaining what is the difference between decimals and negative numbers. So this actually, when you understand it, it is incredibly obvious, but if you don't understand it yet, like basically why I'm explaining this, I remember having a lot of trouble trying to figure this out before the current date, which was a long time ago. Anyways, I used to have, let's use simple English. I used to have trouble understanding this, and I know there's probably a lot of other people who, I know some others who have had trouble understanding this, and there's probably a lot of people. So, I'm going to basically explain it. So, basically, this is a number. So hopefully that can be seen. Let me just check the camera. Yes, that can be seen on the camera. Alright, that is a number, as you are aware. This is another number, that's 1. Then there's 2, 3, 4, like that, and these keep going. These are all your positive numbers, basically. And actually, let's try explaining this from a different angle. This angle. So let's just briefly talk about where you would have heard of these types of numbers before. I'm just going to write them down, continue writing them actually, as I was doing before, just for clarity. And we'll talk about the real world as to where you would have seen these before. So these are negative numbers, these are positive numbers, and decimals are things like, let's say 0.32156 something like that. Or it could be like 1 point whatever, something like that. Could be whatever. But anyways, decimals have this dot and then they have numbers after them. Negative numbers have a minus sign before the number, basically. And where you might have seen these kinds of things before in the real world is things like thermometers, for instance, use negative numbers all the time. In computers, I don't remember where I've seen this specifically, but decimals are all over in computers. If you use computers at all, you'll have seen decimals. And different things like that. And I'm assuming that you've already seen all that before if you're watching this video. So you probably have at least heard of negative numbers and heard of decimals and stuff like that. So, the next question, basically, that I would have is, where does the confusion come from? I think where much of the confusion has probably come from is because of something. I'll demonstrate it right here. So, basically, you have a number, like let's say, let's go over here so that we have enough room for later if we need it. So let's say a number like 2. You have a number like 2. You go less than 2, you get 1. You go less than 1, you get 0. You go less than 0, you get negative 1, like that. You go less, you get -2, like that, and stuff like that. And one thing that I'm pretty sure I've heard before, although I can't remember where actually, maybe a lot of places, but is what I've heard is that decimals are, like, let's say you have a decimal of like 0.5 or something. That's less than 1. So I guess it would just be natural to assume that being less than 1, if you're thinking in numbers, simple numbers like this, then less than 1 would be 0 or -1 or -2 or whatever. So, I don't know, you might assume that 0.5 would be like -5 or something like that. I don't know. But I think that's basically where the confusion comes from, is like, so if negative numbers are less than 1 and decimals are less than 1, then they must be the same thing. And that's probably where the confusion comes from. But once you see it, it actually makes a lot of sense. Is basically decimals are less than 1. Well, unless you have like 1.5 or something like that. If you have 1.5, then you have 1 plus a decimal. So the decimal's still less than 1. But anyways, complications. Just forget about that. So basically, once you see it, it makes a lot of sense. So let's take this number line thing from before, and let's extend it out a bit more. So let's make it bigger. So let's put over here, let's put this as 4. Let's see, how am I going to have enough space for this? Let's put -4 over here. And let's divide this up. So let's put 2 in the middle. -2 actually, because it's on the negative side. 2 on the positive side. 1, 1, 3, 3. There we go. So now you've got 0, whoops, sorry. -3, -1. There. That's why it's a good idea to check your work. So 0, 1, 2, 3, 4, and keep going. And those are supposed to be dots. They look more like upside down birds. And you can keep going this way. There we go. So this is your number line. If you were to take, say, 0.5, like this over here, then that would go... Actually, let's make an actual line for it. Here goes a line. And let's put our numbers in here. So just make a little tick just to show where they are, so that it's a little easier to tell. And a number like 0.5 would go right here. 0.5. So let's see how I can explain this better. Basically, what a decimal is a fraction. It's not a negative number, as you've probably figured out by now. But basically what a decimal is a fraction. So, like, for instance, let's say if we had a pi, like that. So, let's put our pi over here. And let's take this pi. It's kind of squished over in the corner here, but oh well. Take the pi, and we can take this pi and divide it in half, let's say. Then you have 1 piece out of 2. If you take the pi and divide it into tenths, then you have... Oh boy, how do you draw tenths? I've never actually tried to do that before. Okay, well, let's just do it sort of the best that I can here. Something like that. There we go. So, now you've got 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you add a tire, then it could look like a bike wheel. So, anyways. So, you have this pi here, with a tire around it for some reason, and it's divided into 10 pieces. So you have, let's say, wait, did I say 1 out of 2 over here? You have 2 pieces out of 2 over here. If you were to, from before, if you were to take one of those pieces that we had when we had 2 pieces out, then you would have 1 over 2 pieces. Okay, so let's back to this example of the 10-piece pie. Basically, if you were to take, say, this 1 piece over here, then you have 1 piece out of 10 pieces. And that's basically what it is. And this 1 piece out of 10 pieces thing is the same thing as saying 0.1. The decimals, as you go down, basically, let's take this number over here because I already have that one written down. The decimals, this is your ones, this is the whole pies, so to speak, and then that is every 10th of a pie. So when you divide the pie into 10, how many extra tenths of a pie? So here, go back to this 0 here. This 0, we have 0 whole pies. I mean, not in this diagram, but let's say, theoretically, in this number, we have 0 whole pies, and then we have 3/10ths of a pie, and then we also have an extra 2/100ths of a pie. So if we were to take this piece and divide it into 5 pieces, however that would work, something like that, I think that's roughly 5 pieces, and then divide it again, and then you get like that, and so supposedly that's divided into 10 pieces. It's a little small to be able to tell. So that would be 1/100th of a pie, the total pie. Hopefully that makes sense. I'm kind of moving really, really fast, so if anything doesn't make sense, if you'd like me to elaborate more on a certain point or whatever, let me know in the comments, and I'd be glad to, assuming I get the time, to do another video explaining that one point or whatever. But basically, that means you have 3/10ths of a pie, you also have 2/100ths of a pie, you also have, if you were to take a pie and divide it in 1,000 pieces, you'd have 1,000th of a pie, 10,000th, 100,000th, millionth of a pie. That is a very small number. I wouldn't want to eat a millionth of a pie. Well, I mean, I suppose a millionth of a pie is better than nothing. But anyways, so yeah, so that's basically what a decimal is. So that's why decimals, actually, I don't suppose I said this specific question before. I'm answering a question that I didn't ask yet. So I should ask the question. The question being, why, if you go small enough in your decimals, so let's say 0, that looks like a 6. Let's redo that. 0.000000000000000000001. Let's say if you went to a really small number, or even smaller, the question, I think the question basically often is, if you go small enough, why don't you go down past 0, basically? And, like, why doesn't it get, like, basically, why doesn't it become a negative number when you get small enough? And that's basically why, hopefully this is making sense to you, is because it's fractions of a pie. If you have a tiny, tiny amount of a pie, you still have part of a pie. Versus if, like, let's say you had 3 pies, let's just say these are pies, and you were to take 1 pie and eat it, then you'd have 2 pies. If you were to take another pie and eat it, then you'd have another pie. And if you were to take another pie and then eat it, then you'd have then basically be left with no pies. And then you remember that your friend over here, Mr. Stick Guy. So, you have your friend Mr. Stick Guy over here, and then you remember that you promised Mr. Stick Guy that you would give him one of your pies. And you don't have any pies left because you just ate them. So then, basically then the next pie that you get, you'd have to give it to Mr. Stick Guy because you promised him a pie. So you have -1 pies, because if you get one pie, it's not actually yours, it's Mr. Stick Guy's. So that's basically the idea of what negative numbers is. And so hopefully that explains the difference between decimals and negative numbers. Basically, decimals are fractions of a pie, or of whatever, but we're using pies for the example. Basically, decimals are fractions of a pie, whereas negative numbers are missing pies, maybe? I don't know. But basically having like less than 0 pies. So if you got a pie, then you'd have to give it to the somebody or whatever. That kind of idea. Hopefully that explains the difference between decimals and negative numbers. So if there was anything that was at all confusing about this or whatever, then leave a comment and let me know, and hopefully I will have the time to maybe do a follow-up video or do whatever to try to explain a certain point better or whatever. But yeah, so for now, hopefully you enjoyed the video, and this is Handy Andy signing off and all that, and so see you later. Bye-bye! Oh, wait. Wait. I forgot I should make a sign. This is sign. There we go. That's the sign. And then this is the sign pole with the sign off of the pole. There you go. Signing off. Or something. I don't know. Anyways. And then we just have to take the sign and add a couple of screws and stick the sign back on. Sign. There we go. So yeah. So now we've repaired the sign, and this is Handy Andy signing off, and yeah, hopefully you enjoyed the video. Bye-bye!